Welcome everybody to this webinar that we're running at Bristol Technology Festival. My name is Luke Hampson. I'm the Partnership and Outreach Manager for Geovation, which is an Ordnance Survey initiative. I'm just going to steal a few minutes at the beginning of this webinar to tell you a bit about Geovation. The webinar itself, of course, is all about, it's an introduction to Ordnance Survey's new Data Hub portal, and my colleague John Hoops is going to deliver the presentation. So just before I kick off with these slides, we're going to take questions at the end of the session. So if you're not familiar with Hopin, on the right-hand side, you should see a chat area there. So yeah, please do, as the session goes on, put your questions and we'll raise those with John at the end of the session. If there's anything mega urgent that you just don't follow, there might be an opportunity to interrupt John, but hopefully we won't disrupt his flow. So yeah, without further ado, I'll just tell you a little bit about Geovation. So as I mentioned, it's an Ordnance Survey initiative, and it consists of a community network, around 2,500 members now, actually strong, which is growing. We focus on geospatial and property tech, essentially, and we run an accelerator program from our hub in London. So basically, we're supporting early stage startup business ideas that are currently using geo or property data. We're in association with HM Land Registry and the Registers of Scotland, and we're a team of around 15 or so, usually based from our hub in London. Obviously not currently, but plan to be there hopefully in the not too distant future. Over the 10 years, Geovation, we've given away 2 million in grant funding to companies, and those companies, around 125 of them, have gone on to raise 86 million pounds in additional funding themselves through other routes. And yeah, high success rate in terms of 79% of them still active, which is quite good for the kind of early stage startup world. Lots of failure goes on there. Because geography touches everything happens somewhere, as we like to say. There is a real broad section, cross-section of kind of like market sectors that we cover. Yeah, so if you're curious and want to learn more about this, please do get in touch with me, follow our socials, and we'll be able to sort of tell you more about that. Geovation wouldn't work as well as it does without its partners. I've mentioned HM Land Registry there and the Registers of Scotland, but these partners either financial or in-kind kind of benefits to us, and yeah, it really works well that way. And the wider ecosystem, so you might well recognize the logo on the left-hand side there, the engine shed. We have a network of Geovation partner hubs that are based around GB. So obviously Bristol Engine Shed, we have Innovation Birmingham, Manchester, and Cardiff as well. So the partner hubs currently that we have there, as well as our hub in Edinburgh in London with our Geovation Scotland team up there. So a few of our companies have kind of graduated onto other funding routes and accelerators such as Y Combinator, and yeah, we like to think of them as part of our wider ecosystem. That's going to skip over that one because that's what it's all about today, about the OS Data Hub, and going to pass you over to John now to run the session. I hope you enjoy the talk, and like I say, please do get in touch if you have any questions at all about Geovation. Thanks a lot. John, over to you.
All right, thanks, Luke. I'm just putting out a quick tweet to make sure that I've got it out in the world to my 240 Twitter followers that I'm on the stage at the Bristol Tech Fest. Hi, everyone. My name is John. I'm developer advocate at Ordnance Survey. And I'm here to talk to you today a bit about the OS Data Hub and a little bit about spatial data and how it works. It's a fascinating field, and it's a really exciting space to be in. Ordnance Survey has almost 300-year tradition of innovation in the cartography community, and that continues into the 21st century. So I'll go through the Data Hub, what it is. I'll talk a little bit about OS, spatial data capture and processing, and how we get the authoritative data that we provide, and then really kind of walk through what APIs are available through the Data Hub, how they can be connected to and accessed, and it's really meant to inspire creative thinking around how OS data can be useful to you. one of the big initiatives we have within Ordnance Survey, and really actually across the UK government, is to unlock the economic potential of location data in Great Britain. As one of Britain's authoritative spatial data providers, Ordnance Survey is at the center of that strategy. So that I'll talk a little bit more about the sort of history and reasoning behind that in the talk. But let's go ahead and get started. So this is going to be a bit of a combo of the slides and then live demos, which is always a risk when you're giving live demos of tech. So bear with me, but I think we've got some exciting stuff to show off. So Ordnance Survey is the UK's national mapping agency. We are a data company, and I think it's fair to say we're probably one of the oldest data companies in the country. Ordnance Survey was stood up in 1791 to make the first accurate map of Scotland. And since then, as I said, we have been at the cutting edge of map making, really pushing the discipline forward, and ultimately providing location data to the British public and private sector and government and military to help them navigate the world. So the most kind of familiar to most Brits are the paper maps that we provide, which help hikers and cyclists and road trippers make their way around the country. But we also provide this data to a whole range of other stakeholders and users, ranging from seed stage startups at Geovation all the way up to some of the biggest utility providers in the country, to help them make more accurate assessments about their work and to create new innovative ideas and propositions to provide to their customers. So at Ordnance Survey, being this an authority that is making available a very accurate representation of the physical world in Great Britain, we go to great lengths to make sure that the data that we put out is trustworthy. If people are basing decisions that their businesses rest on, that their lives rest on, that their safety rests on, this is crucial. So I'm going to tell you a little bit about the process that we go through to make this data available and you know, put it out into the public with the confidence that we can stand by it. And I guess, you know, if we look back in history, how did we make maps of the world? It's kind of hard to imagine, for me at least. I'm a millennial, so I have grown up with GPS my whole life. It's hard to imagine being in the world and not knowing exactly where you are, but that's the way it has been for absolutely most of human history. And it took people a really long time to work out how to measure their position on Earth based on where stars and the sun and the moon were, and also based on where certain points of interest or landmarks or features around them were. So as I said, in 1791, Ordnance Survey sent out a team to map Scotland, and we created far and away the most accurate maps of Scotland ever created to that point. And that just started this long history of Ordnance Survey making these very accurate maps of the world. The way that used to work is that, and to an extent it still does. By the way, this is not a photo from 1791. There were no photos in 1791. And actually, this isn't a map from 1791. I think this is from the 1800s. But John, the way that, yes.
Sorry to interrupt you there. I just want to make sure that you're, I'm not seeing your slides at the moment.
Oh, really?
I'm not the same for others. If anyone might be able to sort of tell us in the chat if they're seeing slides, yes or no.
Better?
Yeah, that's looking, yeah, looks like it's loading. Just a sec. Coming up. There we go. Thank you.
Okay,
cheers.
Good catch. That would have been a pretty lame talk if I hadn't had slides the whole time. So historically, yeah, this map, as I said, is not from 1791. It's from the 1800s. We got it from I captured this image from the National Library of Scotland, which has a really amazing historical maps explorer, where you can go compare historical maps with contemporary maps. They were one of the first users to get on the OS Maps API, which is one of our mapping APIs. But people used to go out and they used to take measurements based on known positions of exactly where landmarks were. They would point a very accurate compass, and this instrument would have a way to measure the angle, that the kind of angle of sight, and in that way they could kind of map out these points and then take it home and back into the office and analyze it and perform these calculations and end up generating these accurate maps. This still goes on to an extent today. So in 2020, Ordnance Survey has a team of surveyors that are out in the world. We use electronic instruments that are incredibly precise now, but we have a team of surveyors that are going out and taking measurements of the exact positions of essentially the geographic features that we interact with in the world every day: buildings, sidewalks, roads, rivers, forests. All of that is represented in the databases that Ordnance Survey maintains. So one of essentially our flagship, kind of most accurate high resolution data set we have available is called the OS Master Map. And this has about 500 million features, and I'll talk in a minute what exactly I mean by the word feature. It's updated hundreds of thousands of times per day. You can imagine a building gets demolished or built, right? Or a road name changes. As providers of authoritative data, not only do we need to have data that's accurate in space, that accurately depicts where these things are, but it also has to show have accuracy and currency in time. So we are out all the time measuring and capturing data about Great Britain and using that to update our data sets, and in turn obviously provide that to our users. So lots of exciting cutting edge research going on at Ordnance Survey, using new capture techniques, using new analytics techniques to be able to provide more accurate data, bring it to market faster. We also are respond to need. We had a really quickly, our legal team drafted up a COVID license, which would make it so that anybody working on a solution to respond to the coronavirus crisis earlier this year could do so with really permissive terms. So, right, let's talk a little bit. Okay, yeah. So we've got the surveyor here, but now we have some technologies that weren't around in the 1790s, and essentially, we now have airborne vehicles, aircraft, that have the ability to mount these very, very high resolution cameras on. So Ordnance Survey has a few aircraft that are flying around the country every day that it's safe, taking these very, very high resolution photos of the Earth's surface, and capturing all the features, all the geographic data. We bring that into Ordnance Survey technology systems, a data pipeline, and we analyze and process that, and ultimately create these maps. So I want to tell a little bit about this data, the spatial data lifecycle, which is going to give a little bit of context to where to the data that you're consuming from Ordnance Survey. So the first layer here is raster. These are images, photographs that are taken of the Earth's surface, and they really can be, I'll get into it in a second, but this is kind of the raw data, right? This can be the colors of the Earth's surface. It could be infrared spectrum, so there you can capture a bunch of different frequencies in the electromagnetic spectrum using these specialized cameras. And each one of those frequencies or channels carries information about the Earth's surface. So for example, vegetation affects the reflection of infrared light in a particular way, that by analyzing this data, you can see what areas are vegetation, what might be road surfaces, what might be solar panels, and so on, using analytics techniques on that data. You also can capture and calculate the height of the terrain at particular points in the Earth's surface, which enables you to create another type of raster image, which is called a digital elevation model, where each pixel in this image has the height of land at that particular area, which, when applied to certain analytics techniques, you can generate these realistic looking images of, for example, the way that the shadows would be cast on the land if the sun were in a particular location in the sky. So using these raster, and by the way, just to be clear, technically, this is these are contour lines, so these are vector geometries, but they're colored according to the height above the land. So I put that in to represent the digital elevation model raster image. But okay, so we've got this raw data where you have these rows and columns of pixels that each pixel represents a value, but how do you then identify the geographic features that we recognize as humans? We look at a street, we don't see a bunch of pixels of dark light that are reflected off the asphalt. We see a street, it has a name. So in order to represent this mathematically and make it useful for computers to visualize and analyze, we create what's called a vector geometry. And a vector is essentially a points and connected points and enclosed spaces and enclosed volumes in some kind of space, really. So in this case, this is a vector representation of the waterways in a particular area in the UK. So we've gone and we've mapped the center of these waterways by taking the coordinates of each point, and this enables us to identify the water network and analyze where it might be flowing or where a boat might be able to travel. You do a similar thing with the road network, where you're able to say, all right, here's the beginning and the end point. This road segment is connected with this road segment. So we can, if we're doing an analysis to say, all right, well, we want to route a car from A to B, there are analytical techniques to be able to figure out the shortest path to do that based on our road network. These road segments can be bidirectional, where you can travel both directions, but you could also specify that a certain road segment is, you can only travel in one direction. So we're starting to kind of build up this picture of going from our spatial data capture using raster imagery to identifying these geographic features. I should also say, so this is a remote sensing technique for capturing spatial data. This is also what you might have our surveyors out in the world measuring. So they might go out and measure the exact center of the road, and with their instrument take measurement of the exact coordinates of that center line, and in that way also create this road network. And then while they're out there in the field, they might say, all right, this is called, you know, Regent's Road or whatever, King's Road. Obviously from a satellite image, you can't really tell what this road is called. You can only tell that it's a road. And then the next layer on is actually these more, I think of them as more kind of conceptual geographic features. So geographic boundaries, political boundaries, those kinds of things. That's another layer that is added on top, that are vector geometries that we include in our data sets that are available for consumption to the public. And then the last step, what do we do with this information? Well, we want to make it useful, and we do that by visualizing it. So in this example, we have a vector tile data set, and each of the buildings has the height of the building. And that enables us, using some very powerful, cool software, to create an interactive 3D model of the city based on OS data and a couple of lines of code. And I'm going to get into that in a second, but just to kind of emphasize the difference between these two things. If you're going to be working in spatial data, it really helps to kind of conceptualize these two sort of types or classes of spatial data. There's raster and there's vector. And the way that I think of it is, okay, we've got these two features, right? We've got this triangle area. This is a polygon. And we've got this however many sided figure that is, hexagon or septagon, something like that. How do you actually represent this mathematically? Because a computer can really only work with numbers. This is how, and this might be like not really make sense, but here, a raster grid, we have rows and we have columns. Each row, each cell, each pixel is has a number. These are regularly sized, so each one is the same width, the same height. And in that cell, in that pixel, you have a value or a number. And in this case, we have the most simple, basically it's a binary value. It's a 0 or a 1, white or black. And in that way, we can create this image that does represent some kind of space or area, but we do it mathematically. In each of these cells, it doesn't have to be just 0 or 1. You could have a much bigger number, so it could be on a spectrum, or you could even have multiple numbers. Those numbers, as I kind of mentioned, are captured by those multispectral sensors that are on satellites that are orbiting the Earth, that are on planes flying around, that are on drones or other unmanned aerial vehicles. A vector geometry, on the other hand, is represented as a sequence of coordinate pairs or points, right? Okay, so how does this work? How does this show that? Well, if we look at this as points plotted on a coordinate system, if you connect them in the order that they're represented here, you end up with this polygon drawn, and this is the way you represent a vector geometry. This could be the outline of a building or a school or a country or really anything. Now, this is a sort of XY Cartesian coordinate system. Part of the challenge is that the Earth is not flat, contrary to what some believe. And hopefully no one took offense in the audience. The Earth is a sphere, or roughly a sphere. So in order to locate a specific point on the Earth's surface, we have a center point, and we choose an origin, which is 0, 0. And then rather than us measuring in terms of 1, 2, 3, 4, 5, 6, 7, the sort of regularly space counting sequence up the X and the Y axis, we measure it in terms of an angle between a line that's drawn from the center of the Earth to the origin and somewhere else on this meridian, which is called the equator. That's the line going around the Earth's center. So this angle is, this, for example, is a 90-degree angle. So this would be 90 degrees to the west of this meridian, or 270 degrees to the east of this meridian. That would be this particular spot. And then likewise, we can draw an angle from the origin up to the North Pole or up to the South Pole along the prime meridian or another vertical meridian. And that enables you to identify how far up the Earth's surface essentially a point is. So with this, we're able to identify any location by its latitude and its longitude, or actually in computing, you'd flip those because longitude is the X. Oh, I think I made a mistake on these slides now that I mention it. Longitude is the X and latitude is the Y. So longitude is the horizontal, latitude is the vertical. And then you can also specify where it is in relation to as far as the distance away from the surface of the Earth, which is a very complex question and a very difficult thing to measure in practice, because the Earth is not a perfect sphere. But that's the altitude. And then the last kind of dimension in this is time. As time goes on, things might change, so you might want to have some time dimension to it. Here, I've got a mistake. This is not the Y. Longitude is the X, latitude is the Y, which is a lot of times in computing, you'll see coordinate pairs represented as longitude then latitude rather than latitude then longitude. The speaking convention is to have latitude and longitude, but in math, it's often X then Y. Right, okay, so just to really quickly kind of show this vector, I got this really useful tool, which is called geojson.io. Let's say we want to create a point at Explorer House, which is in Southampton. I I come in here and I just go ahead and click this. Now I've got to find Explorer House. I started at OS about a week before lockdown started, so I've only been into Explorer House a few times. Well, I can't exactly, yeah, here it is. There it is, I think it's here, yeah. All right, so if we click that, what that does is that puts this coordinate pair in. This is the X, it's negative 1.47 degrees away from the prime meridian to, well, negative 1.47, which is 1.47 degrees to the west, which makes sense because Southampton is a bit to the west of Greenwich. And it's 50.9 degrees north of the equator. Likewise, we want to go ahead and draw a line. Let's go ahead and clear this out just to keep things simple. So if we wanted to draw a line, we could draw a line string on the Earth's surface. And this is represented as this array of coordinates, which is a sequence of coordinates. Each coordinate represents a vertex or corner on that line, a point on the line. And then the software knows to draw and connect those points with a line string. And then the last one we'll do is, let's trash that. And then the last one we'll do is a polygon, which similar to a line, it's an array of coordinates, but the difference is, A, we tell the computer that it's a polygon. By the way, this is GeoJSON, geographic JSON, in case you don't know. It's a way of representing vector geometries in code. The coordinates are, this is a sequence of coordinates, again, the vertices of the line, the corners of the polygon, excuse me. But if you'll notice, the first one and the last one are exactly the same, and that's to show that actually this closes and comes in where it's, and ends where it starts. Right, okay, that's enough background on spatial data. Let's talk about the Data Hub. So the Data Hub is an initiative and a platform that's come out of the launch of the PSGA, which is the Public Sector Geospatial Agreement. And this really defines Ordnance Survey's job over the next 10 years, which is to build Britain's location expertise and unlock the economic potential of location data for the British public. And we're doing that by capturing and making available new data, giving new ways to access that data, and making it easier and giving people more freedoms to share on the data and insights or data they derive from the data. I don't want to dwell too long on this, but the Data Hub is really kind of one of the main ways that we're giving new ways to access. In the past, if you wanted to get OS data, you would have to do a bulk download or even something that, well, or actually order a CD or DVD to be mailed to you. Now we have the Data Hub, which is our portal to connect to and access Ordnance Survey data through a series of APIs. An API is an application programming interface. So this is a way for computers to essentially interact with other computing systems in a standardized way, so that you as the developer don't have to deal with the complexities of the other system. It has an interface where you can go ahead and you can say, okay, well, I want this. And if you structure it in a standard way and send that message to the other computing system, then it will behave kind of as you expect and respond. So I'm going to give you a real quick tour of the Data Hub here. This is the Ordnance Survey Data Hub. It's at osdatahub.os.uk. I think everyone can see this. It looks like it. So this is the way you get access to a number of different APIs. I'll go through each of one of these in turn and give a bit of a demo. But when you sign up for the Data Hub, you can select a plan. We have an open data plan, a premium plan, and a public sector plan, which is coming soon. The open data gives access to all of Ordnance Survey's open data. It's free, unlimited access, no limits to the amount that you consume. It's one of the most permissive data licenses I've ever come across. We also, through the Data Hub, have available OS premium data sets, including master map topography layer data. Accessing premium data carries a cost. It's a per transaction cost, so it's a small amount of money for each request that you make to the API to send you premium data. And we essentially keep track of that cost that you accumulate on your account. But up to £1,000 of premium data every month is given away for free, and then only once you kind of surpass that threshold, then we start charging the card. We have some pricing information. If you're actually really interested in looking into this, I definitely encourage you to reach out and get in touch with me or the pricing team. We can explain and walk through what would be the most useful, suitable plan. This you can get up and running kind of on your own terms, permissionlessly. You can just start for free and sign up and start using it. You don't have to get in touch with us to start using it. But if you have any questions, you can. We also are dedicated to making our data available and useful to the public sector. So we have a public sector plan that's launching early in 2021, which is essentially unlimited open access to all OS data, including premium data sets. So this is for PSGA members, which are public sector organizations. But if you are a private sector firm that's providing services to a PSGA member, the data that you consume for that customer fall under the public sector plan. So if you think that might be you, also reach out, get in touch. We can get you in touch with our licensing team to talk about this. All right, that's enough about the money stuff. Let's talk about the data. Right. So when you create an account, you'll end up with this dashboard. We organize our dashboard into a series of, we've got this kind of overarching dashboard, and then you can go ahead and create a project. So I'm going to go ahead and create a new project here, which we'll call Bristol. And when I create a project, I need to add APIs to the project. I'm going to go through each of these in a second, but this is just to kind of show you how to get set up. When you do, it creates an API key. This API key needs to be provided when you send a request to the Data Hub API endpoint, and that's how we keep track of what you use and know what data you have access to. We have a lot of you can use this in production. This is all production ready. We also have development mode if you're going to be using a lot of data, but you're experimenting and building services and products internally. You don't have to pay for those. Okay, cool. Let's move on. Okay, we went through the Data Hub plans. We went through the dashboard. I guess I should mention really quickly, we have the documentation, which is for each one of these resources. We have overview, getting started guide, and technical specification with a lot of details about that particular API, everything you need to know to get up and running. We also have a series of examples that have code snippets that I'll go over in a second. Great. Okay, so let's talk through the APIs, and I'm conscious we've got about 15 to 20 more minutes before we want to take some questions. So this is going to be a pretty quick windscreen tour, but I want to give you a sense of what's available. So we have 6 APIs that are available on the Data Hub now that you kind of interact with, as well as a downloads API, which is for downloading open data, full data sets. The first one we'll talk about is the Maps API. So this is a raster tile service, and a part of the reason I wanted to talk a little bit earlier about raster versus vector data is to frame this part of the talk for those that are a little bit less familiar with spatial data concepts. So just like we were talking about earlier, this is a raster data set where we serve you raster tiles of rendered map images of the landscape of a particular area. This is a really simple, easy to get up and running API. It connects to basically any GIS software like QGIS, ArcGIS, CAD Corp. All those will have ways to connect to this API and use these as your base maps. And one thing that's really cool about this one is these maps were designed by our cartography team. So we have OS cartographers that are thinking very, very hard about the best way to represent this data visually. And we take the data that we have and the rules that they've written, the styling rules, and we create these tiles, these map tiles, and then essentially you put in a few lines of code into your application, and you're able to create this map and put that into your web page, and you have this OS standard map with up-to-date information. This particular one is a good example of the premium data that's available. So at this zoom level, all of these tiles are derived from open data that we have available. Only when you get down into this higher zoom levels here, you just saw, we just ticked into seeing a lot more detail about this area, about this town. These tiles are derived from OS premium data sets, from the master map topography layer. So that is the distinction between open data and premium. If you had a map and people were only ever zooming around on this level, this would be free, unlimited usage, point, period. Once they zoom in, now we're loading map tiles that are going to start ticking towards that 1,000-pound threshold. I have another demo of exactly how the Maps API works. So we essentially, as I say, we specify the details of the maps that we want to fetch. And then when we create this map, we add this tile layer. And this is actually like the URL of where the data is hosted. And then you add it to the map, and then Leaflet, which is the library we use here, fetches these tiles and assembles them in a way that they look like a seamless map. But actually, each one of these tiles is a single small PNG image, PNG, like kind of what happens when you take a screenshot. And it looks like it's all seamless, but actually each one of these images, this is an individual image. When you zoom in, each one of these is divided into 4, and the tiles that are created have more detail. Again, more detail, right? So when we zoom all out, we have these tile images that are a quarter of the country, a fifth of the country. And each time you zoom in, you get an additional level of detail. Here are some examples of the different styles we have. So road emphasizes the kind of the road networks, obviously. Outdoor is a little more oriented towards leisure users and has some of the hill shade I was talking about and the contour lines. Light is really good for base mapping. It has a bit of a more of a muted color palette. A lot of our users are overlaying their own data sets on top of this. And then we have the classic OS, which you'll see is kind of our Explorer or Land Ranger series. The paper maps you get, we've made those same maps available through the API if you want to get that a bit more of like a classic OS feel. Right, okay. The vector tile API, moving on to the vector tile API. The vector tile API is similarly is a tiling API. So it serves the data that you need when you need it, the local tiles, in a kind of a similar way that the Maps API does, where depending on the zoom level, you have more detail in these very small tiles. And then the application only fetches the tiles that you need when you need them. The difference here is, rather than this being a static image of pixels, we actually send the vector geometries, the coordinate arrays, the points of each of the features in this tile, along with some information about what that feature is, a little bit of information. This is a lot of really exciting, really powerful visualization tools have been emerging to work with vector tiles. And this is actually quite a lot lower bandwidth. It's almost half of the data that you need to load a map using the Raster map service. You would need about half that data as far as like the volume, number of bytes to load a vector tile. And on top of that, you have some really, really cool interaction possible. So here's an example of the vector tile API. You can see those tiles kind of loading bit by bit. My internet's a little bit slow in my house. And then we have, because the buildings in the vector tile API, these geometries come with the height of the building, we're able to direct the visualization library we're using, which is Mapbox GLJS, to extrude those geometries and make it look as if they're volumes rather than these kind of flat polygons. And in that way, create a 3D model of London or of anywhere in the UK or in Great Britain. another cool thing about this is to kind of illustrate what I mean. So here we can kind of tilt this up. We can spin this, but to illustrate what I mean by what you can see here is when I'm spinning this map, you see how the labels are actually staying oriented so that they're always horizontal. That's because these labels are sitting kind of separately in the mind of the computer to what they're on top of, and the style is prescribed so that they always stay horizontal. With a raster map, if you turned this this image here, the label would turn with it because the label is just kind of embedded in the image. So lots of very cool stuff you can do with the vector tile API. We have additionally, we have overlays where we have specific features that you can overlay features. So this is a the sites overlay, and here's an example of another thing about these vector tiles. So here we've got this array of points that represent the spatial geometry, the spatial information about this feature. But if you see here, we've got this properties object. This is a place where we can put information about the object. So this could be like, you know, I don't know, location, Southampton. And with this is a bunch of relevant metadata, or what we'll call in the sort of parlance of the community is attributes about that particular spatial feature that are non-spatial. Southampton is not a spatial data, but it is relevant to this particular spatial feature. So with the vector tile API, we serve these vector geometries, and we serve them with a little bit of attribution. The reason we don't put that much is because we don't want it to be too much data. It would really slow down the service. But we do want to provide it with enough for you to be able to do useful things with the visualization and potentially even analysis. So in this case, we've colored these different features based on these properties, what type of feature it is. So here we have a railway station, so we've colored that purple. Here we've got I just clicked the access point. This actually is a hospital, so we color that pink. Here we've got a school, I think. Yes, we colored that yellow. This is an additional vector tile set that we offer in addition to the sort of main base map that we have. And I think it's probably also just worth mentioning that in addition to this cool interaction, we can customize the map. Each one of these layers, and we can actually customize the I'll pull up an example here. We can customize the individual layers and individual features. Case, I'm going to pull the key I have from here because this is a burner key that I'm going to throw away because now everybody can see my key and could use this to access the data. Here we've got, see, this is what happens when you do a live demo. No, I'm not going to be able to do it. All right, that's not an issue with the API. That's an issue with my code. So, but in this case, anyway, we've custom styled these individual features based on the attributes that we've received. So this is a much more sophisticated data set and API when you want to customize the styling for your visualization. We've also had some users using vector tiles for their analytics pipelines, doing machine learning on these. I think that's really cool. Right, okay, let's move on. Kind of the last one in our sort of core APIs that we offer through the Data Hub, I think kind of like the workhorses is the Features API. The Features API is a new way to directly access OS data. So this is sort of extending this, the vector tile API is kind of the bridge. So that's vectors, but it's tiles. The Maps API is raster tiles. The Features API is vectors. So these are vector geometries. You can select the data that you want when you want it. And this is really, really powerful analytics for analytics. And it's really, I talked a little bit earlier about how these vector geometries come with limited attribution. Our Features API serves with full attribution. So if we go ahead and we select feature type where we say like topographic area. So this is coming from the master map topography layer. Here we've got a couple of these geographic features that are overlaid on the Maps API, but these geometries are fetched from the Vector Tiles API. Here, or sorry, from the Features API. This is the geographic JSON, GeoJSON, that we received from our request. And this includes not only the geometry, which is the geographic data. Here's that array of coordinates that I was talking about. But here we also have all of the properties that are associated with that particular feature. In this case, it's a building, it's man-made. Here's an identifier for how to fetch it from our database, some codes, the area, when it was last changed, what happened when it was changed, there's the height. All of this information is stored in our databases and available to users for whatever they want to do with it, right? As long as they're passing this value on to their customers, you can analyze it, you can use this for visualization purposes. So this is an example of these vector geometries that are getting served with full attribution, really powerful for analytics purposes. Right, okay, let's move on. I'm just going to touch on these last few, and then I really want to leave a few minutes for questions. So the Names API, this is a geographic directory for identifying places. There are two functions here. You got find, where you can send in a name or a postcode, and it'll send you back where that is and some information about it. But then you also have nearest, where you send in a location, and it'll send you back the nearest identifiable place to that location. So this would be sending it coordinates. We do have an example of this. Here's the Names API. So for this, we have a geocoder where we could say, for example, like Hailing Island, right? When we click this, it zooms to Hailing Island. We've written the code to make it zoom to this map, and this is a OS Maps base map. But from the Names API, we're getting the information about where's Hailing Island, where should we point this map to go and show the user where it is. Likewise, with this reverse geocode, if I click, it takes the location of where I clicked, sends that position to the Names API, which sends back the nearest location, which in this case is this postcode in Westminster. Cool. Oh, and you can filter by category. The linked identifiers API, this is a really interesting one that a lot of people, especially in the prop tech community, are getting really excited about. So we have this world with all these physical features. We can debate what constitutes a feature, but we also agree, like, the outlines of a building are a building, and the outlines of a property are a property, right? Each enclosed polygon is represented in Ordnance Survey's databases as an individual feature and is associated with a particular ID, which is called a topographic identifier, or TOID, right? I showed you this a minute ago. Here's the TOID, OSGB1, bunch of zeros, 6, right? However, in other databases across the UK, you don't need to know, all right, well, there's this sidewalk on this property, and then there's this little fountain in this building. You just want the outline of the entire property and to represent that by a unique identifier. So for that, the community has adopted the UPRN, the unique property reference number. Within a property, so if you imagine here, let's say this is a property. This might have 50 different actual individual features represented in Ordnance Survey, and each of those features has a TOID. The linked identifiers API is really useful because you can send it the UPRN, and it will send you back all of the TOIDs that are contained with that UPRN. And likewise, you can send it a TOID, and it will send you back the UPRN that TOID is contained in. So this is a really powerful tool for linking together data sets or databases that have different identifiers used. It's not returning any spatial data. You then need to take those TOIDs and go send it to the, say, features API and say, send me back all the features that match this TOID, or the one feature that matches this TOID. But it's really, really useful for linking these identifiers together, which is why it's called the linked identifiers API. The downloads API is really for making the process of discovering and downloading OS open data really, really simple. So I can just show you here. We've got a graphical interface for this, but we also have a really easy to to use machine readable interface. And this is, at the moment, it's open data sets, raster and vector. You can download boundary lines, you can download maps, you can download the centroids of all of the postcodes and what postcode they are. We've got the linked identifiers data set for cross-referencing these identifiers if you want to bring that on board and do that kind of analysis in your own terms. Open names, open rivers, open roads, and we have a terrain 50 digital elevation model so that you can go and create those hill shade analyses that kind of analyzing the slope of a particular area of land and so on. This is all available through the Downloads API. We will be moving premium data onto the Downloads API at some point in the pretty near future, but for now it's all open data. Right, so what could we do with this? Here's just a little demo application we've mocked up to kind of showcase how these all might link together. So you might do a search for a place with the Places API or the Names API. Oh, by the way, we have another API that's called the Places API. It didn't make it into the talk because it's not on the Data Hub yet, but it is coming. So if you're a Places API user, it's definitely worth starting to get familiar with the Data Hub. And if you want capabilities that you haven't seen on this, that isn't quite captured in these APIs, take a look at the Places API because it does some really cool stuff. You might search for a place using these two APIs. You got a base map in the Maps or Vector Tile API. You might overlay a feature from the Features API or another one of these APIs. You might have information about that feature, again, from the Features API. Use a mapping library like Leaflet or Mapbox.js to actually visualize the map. You can switch map styles, which you can do based on the 4 styles the OS cartographers have designed in the Maps API, or any style you want. You can create your own style for the Vector Tiles API. And then you can load that metadata I was talking about into the sidebar where you've got additional information or, like say, attribution about those spatial features, as well as additional information from the linked identifiers API. So this is just like a little app interface that you can imagine how these all might link together. Right. All right. Okay. Not too bad. Not too long over. We've got about 7 minutes for questions if we want to ask for any clarification or anything like that. And again, I am available for to answer any questions or help if people want to talk about how to do this. You can email me. My email's there on the screen, or you can tweet at me or message me on Twitter at JohnX25BD. Thank you. Thanks for listening. I hope it was useful. Luke, did you get any questions?
That's great, John. Mega useful. Thanks very much for the whistle stop tour. Yeah, just want to send out some apologies to those folks that got the wrong link signing up to the event. The reminder email went out with the wrong link, but we've got a full record for everybody. So if you missed a bit at the start, we're going to get that out to you. Hopefully, we're going to go at them the order they came in. Anna Clark put a question whilst you were talking about the kind of suite of APIs that we've got in the Data Hub. She said, is the data held on one server or scattered across different servers areas?
So that's a good question. This is hosted on cloud infrastructure, and it is kind of fault tolerant production grade. So I don't know the exact details. I'm not on the engineering team, but I think it's a number of different servers, and that's a good question. I don't know if we've got kind of local clusters, because obviously OS data is GB only. So most of our users are in Britain. So we have an advantage where we don't necessarily have to worry about serving data to all parts of the world at scale. But that's a good question. I don't know. I don't want to answer wrong, so I'll just say we use cloud infrastructure, and it's it's all heavily tested and production grade, because we want to make sure we, in addition to providing the authoritative, accurate data, it needs to be available all the time. We need to make sure that the uptime guarantees are there.
That's it. Thanks, John. And if you want to know more, if you need to, do not hesitate to get in contact with Anna. We can go to others in the team at OS to tell you. Yeah. Find out what we can tell you. So thanks. Next question, because we have got a few more. Just conscious of the time rattling on it. This one's from Jonathan Swyboda, and he asks, does the 3D layer cover the whole of the UK? Yeah. So everything that I showed you is UK wide. Obviously, there aren't
too many buildings in the moors of Scotland, but yeah, that's one of the advantages of OS is we have a national mandate to map the entire country. So we have the same caliber of data across the entire country, which is a contrast to other data providers that really just focus on the urban environments where they have the most usage. That's great, but it means if you zoom your map to rural England, you don't get much of anything. So yes, it is GB wide.
Yeah, great stuff. Thanks, John. And next question from Kevin Casemore. He asks, he might have missed it earlier, but I don't think he did. How does the OS Data Hub keep their data up to date, particularly for the vector data, the buildings? For example, if a large building is going up, will this be represented in the vector data over time?
Yeah, so it's a really important question, and it's something that we've been working really hard to make sure that our data is the most current it can be. So we have this team of surveyors and pilots out taking measurements of the UK all the time. We have a pipeline where we bring that on, we analyze it using machines, and we analyze it using humans in some cases. And we have a process where we go through to actually get it to the point where, all right, we've gone through this, we've accepted that this is kind of the OS standard authoritative data. So now let's bring this into our public facing databases. And then based on this kind of master data set, we create these tiles, these map tiles, we create the vector tiles, and we create the spatial data that you would access through the features API. It depends on the data product that we have, but typically that lag from capture to our database is, I think it's like 6 weeks to 6 months, depending on the data set. Now, if a building gets built, it doesn't mean our surveyor is necessarily going to be there that day. So it is current, and it's constantly being updated and deployed, or we're constantly capturing the most current information about the country, but it's not like instantaneous. That's something that we're looking into. That's in our R&D department. How do we make it so that time lag between it happening in the world and happening in our data set is shorter and shorter and shorter? But yeah, and that's a tradition, right? We've constantly been bringing it. Used to be build a bridge, like maybe a couple of years later it shows up on a map. Now it's a couple of weeks. So yeah. So it is current, but I think it's on the order of weeks or months.
That's great. Thanks, John. So penultimate question from Ed Cooper. I think it came up in one of your latter slides potentially, but yeah, presumably the question is, presumably we can add our own attributes to the vector data and add additional vector polygons with attributes on top of the OS vector data in ArcGIS or QGIS or similar. Absolutely.
Yeah. So most of our spatial analytics, I mean, OS data is there to be useful, and often it's most useful when compared with other data sets that our users have gathered from elsewhere or they've generated internally. Yeah, absolutely. And on top of that, if you do some analysis, you can add that on to OS data and create another dimension or another attribute or property in that properties table, and that could be useful for your visualization or what have you. So yes, absolutely. It's meant to be mixed and combined and remixed and all that. Absolutely.
Great stuff. And final question from Adam Orchard. Does the Features API provide a way to retrieve linked features, for example, footpaths that are connected to a road, etc., that could be used for finding walk routes in separate external code?
So that's a really good question. I think you could do that purely in the Features API. The way that you would do that is, in addition to being able to filter by category, you can also filter by location. So you could say, I only want the path network or road network segments in this particular area. But another solution to that may be looking at the linked identifiers API, because there is a way to correlate between TOIDs and unique street reference numbers as well. So the answer is yes, I think so. But I think to answer authoritatively, probably send me a message or an email, and we can have a little bit of a chat of your specific case and figure it out.
Definitely, please do get in touch. There's one last question that's come in. We've obviously hit the
Sure.
hour. Let's just to try and address that, and it might be one that again we take offline and sort of come back to you, Jonathan, in a bit more detail. But he's asking, Jonathan Swyboda, asking, if there's time, could you explain what is considered to be internal business use as part of the premium?
So I'm not the expert on licensing, but from what I understand, internal business use is if you're using this data to inform business strategy, or if you're a real estate company and you're using it to figure out where to invest in real estate, that would be internal business use. If you're a company that's passing on any of the insight or information that you derive from OS data to your customers, then that's not internal business use. So if you're advising someone, or if you're selling access to some dashboard and you have an OS base map, or you're saying, all right, we've done an analysis and we think you should build here, that would constitute not internal business use, to my understanding. But that's probably a better question to ask the pricing and licensing team, because I'm not the expert on that.
Absolutely, we'd be happy to hook you up with that team as well, Jonathan, if you've got further questions. So that's great. That's the hour just over. Once again, thanks to everyone for joining. Thanks to the Bristol Tech Fest team for letting us take this session today. Once again, apologies for the link that went out. That wasn't the right link, but we'll send a recording of this as soon as we can. And we hope you enjoyed the session. We hope you keep in touch with us. So yeah, cheerio, and thanks again.
Great. Thanks, everyone.